Hey there! Today I want to talk about zero-shot and few-shot classification and a relatively new approach that you can use for this, let's say, paradigm. More specifically, it is about prompt engineering and how to use third-party APIs, or let's say large language models trained by some other institutions, not yourself, to perform the task of classification. So here you can see a quick sketch of one way of doing this. So the idea is that we create a so-called prompt, right? That we are going to send over to some API, and the API is nothing else than a text completion model or next token prediction model. And by predicting the next token, we will actually get the predicted class or label. So here specifically, I decided to go for sentiment classification just to kind of make it simple. And let's say we don't have basically any data, and if we do, we just have like a couple of examples of how to correctly do sentence or sentiment classification of a sentence. And I try to color code the different sections of the prompt. So let's go through these sections. We have general task descriptions or description. As you can see, at the beginning, we want to kind of say or state that we want to classify some text, right? And that the model should use the labels below in green. We define what the labels mean. And then again, we have some system message saying, hey, here are a couple of examples in red. And finally, we ask the model to perform, let's say, inference on our custom text. So this is the general idea. There are frameworks like LangChain that kind of do this, but you don't necessarily see right away what's under the hood. So I thought it might be just better to do it from scratch. And yeah, let me just mention that this video was also inspired by a repo from Explosion, the creators of Spacey, prodigy-openai-recipes. So feel free to check it out. More specifically, this one. Here they take it like one step further, and they basically allow you to create your own prompt. They create the prompt templates. They automatically send it over to to OpenAI, and then in Prodigy, which is their text annotation tool, you can actually correct potentially the large language model, assuming it made some mistakes. And I already mentioned this. We will be actually using OpenAI's API in this video. In theory, you can be using anything else, but I mean, OpenAI is pretty big nowadays, so I think it's better to stick to it. And more specifically, we will be using this create chat completion endpoint. This is more or less the code that we need to call in Python, which you can see is pretty straightforward. The API key, I already have it. Yeah, we basically format the messages in the following way. We say that the system, we kind of make sure that the assistant is helpful. And then here, we are going to insert our prompt, right? So the thing that I kind of showed you here, this example will be inserted in the very first user message. And we hope that we get a response with that given label. Yeah, pretty straightforward. And if you're wondering why we're not using the completions API, we could. However, it's a little bit more expensive, like as of right now. And this, let's say, GPT 3.5 Turbo is pretty good from my experience and not expensive. Cool. So I suggest we move to the code directly, and let me create a virtual environment. So let's do pyenv local 3.10.8, and let me create a virtual environment and source it. Activate. Let's do it in all three panes. Activate, and then activate. And the very first thing we will start with is basically a discussion about how we can create the template. Apologize. The way I decided to do it in this video is to use Jinja templates. In theory, we can be also using, let's say, Python f-strings, but I find the Jinja templates like pretty powerful. So let me give you a quick introduction on them. So here, let me create a file called template, Jinja2. And also let's install the Python package, which I believe is called Jinja2 with capital J. We have it. And here let's write our, let's say, classify script to classify right? So we are going to import Jinja here and Jinja2 rather. And also let's specify the path of our template, right? So let's say it's going to be template Jinja2 in the current working directory, which is the case, right? It's going to be here. And let's say in the template, we just say hello world, something as simple as this. And the idea is that we want to take the template, load it in Python, and populate any variables. So spoiler, you can have variables inside of Jinja templates and kind of render it, right? And then it's a normal Python string. So let's do this. We also let's import pathlib. So imported pathlib here, and let's say this is pathlib path, and since this is pathlib path, we can just write open and sf. So we get the file handle, and let's load the template. So prompt template is going to be Jinja2 template, and pointed at the path, right? And finally, to turn it into a prompt, we need to render it. And right now our template doesn't have any variables, so it's enough to just call the render method without any arguments, render. And in theory, if I did everything correctly, we should be getting classify. We should be getting yeah, I messed something up. Yeah, of course, here, this is not the path, this is the file, and we need to read it. Sorry, let's Python. Yeah, as you can see, we literally get hello world. So right now, it's not that impressive, right? But as I mentioned, one of the cool things is that you can have variables. So let's say here, we can just insert, using this curly braces syntax, a variable. Let's say the variable will be a, right? So what we can do here now, we can just say a is equal to hello again. And if I run it, you can see that literally inserted the variable. So now instead of hard coding some text, we can basically have variables, right? And kind of insert them into the template. So that's one very useful feature. A second very useful feature is that we can use for loops inside of Jinja. So let me show you how one can do this. I believe the syntax looks like this. For item in items. So this assumes that we provide a variable called items, but then we can just say item, which will basically just print it out, right? So we assume this is some kind of a list of, let's say, strings, right? And we iterate through every single one of them, and then we add them to the final prompt. So let's do this. So here we keep the A. We don't forget about the A because our template needs it. But here we also provide, let's say, items. And here we will say 157. And let's see what we get. Python classified. I think I forgot to put end4, exactly like the message is warning me. So end4, and let's see again. Yeah, so as you can see, it inserted, that's actually not something we wanted, right? We wanted to have not just item 5 times, but we actually wanted to have the value of the item. And yeah, I'm stupid. We again need to use this variable curly braces syntax. Cool. So we can use for loop. So why is it relevant? Going back to this prompt, right? It would be very convenient to kind of programmatically populate this, and we will need to programmatically populate the labels and also programmatically populate the examples. So we can do both of these through for loops, and these can be just some simple Python lists that we read from, let's say, a CSV file, right? You can make it as complicated as you want. The last feature I want to talk about is if statements. So what you can do is that you can write the following. You can write let's say if, so again, this syntax, if flag, which is some variable, then this is the block, and here at the end we again need to do end if. And if, let's say, the flag evaluates to true, it can be actually both a boolean but also, let's say, a list, right? So let's say if flag was a list with more than 0 elements, this block would be run, and we are inside of the block. So let's give it a try. Here, if I say flag, so now let's set it to true, right? We should be able to get inside of that block. However, if I set it to false, surprise, surprise, we are not going to see it. So yeah, these are the 3 features that are pretty amazing, and that's why Jinja templates are kind of convenient for prompt engineering. But I suggest that now we actually move on to the actual prompt that we will try to create. And for simplicity, right, let's just assume again that we're in a sentiment classification context. So first of all, let's create examples, which will be a list. And actually, maybe one more thing that I wanted to mention before we continue. Here I provided the items as, let's say, a list of strings, but nothing prevents you from, let's say, providing examples. And each of these examples can be a list of dictionaries. So you can say, let's say, A is equal to 7, and let's say B is 8, right? And you can have, let's say, 2 of these inside of this list. The value will be different. And in Jinja, again, very conveniently, you can just use the for loop, but this time around, it is going to be, so we don't, let's say we get rid of these original items, right? We don't care anymore. And let's instead just say examples. But now we can actually use the dot operator to access the key. So we can say item A, right? And here we can say item B. And let's also get rid of this one. We don't care about it. Maybe the hello world, we can keep it there. And the flag, let's remove it. And A, yeah. So let's see what we get. Python classify. And as you can see, we were able to kind of iterate over a list of dictionaries. And that's exactly what we actually want for our real prompt, right? Because for the, let's say, examples or for the labels, our dictionaries will have the key label description. And for the examples, our dictionaries will have the keys, text, and label. Pretty straightforward. So let's create some kind of simple examples. We can use what we have in the sketch, but let's say we have examples equal to, so I will just copy it here actually, but let's indent it nicely. So we, let's say, do something like this, and we say that the examples are, so they have the text, right? And then they have the label. So the text, let's use exactly what we had here. Today was a horrible day. It's a 0, right? If 0 represents negative. So today was a horrible day. And let's say the label is 0. And here we have another one, which was about yesterday was a great day, which is a 2 because it's positive. So yesterday was a great day, 0 and 2. And let's see how it looks like. Let's just make sure that our template looks the way we want. And of course here I need to pass the new examples. So examples like this. This did not work because here we don't have the keys A and B anymore. We have text and label. And let's prepend this exactly like we did in our example with the actual text, so label and description. So we can say label, description, and now we should get a nice, let's say this example section, which looks pretty good. Let's do something similar here for the labels. So let's say we use the same list of dictionaries logic for the labels. However, here we will have let's say the label first, and then we want to actually describe what that label means. So description, and for this example, let's assume we will have 3 labels. So the label 0 means label description. Yeah, so let's say label 0, and the description will represent, maybe here we can just use an integer, like in the template it wouldn't make a difference. Description, what did we write? The sentence, yeah, negative sentiment, the sentence, let's just write negative sentiment. Here, let's do the same thing. 1 here, and we say pause or neutral sentiment, and finally we have 2 where we say that we are dealing with a positive sentiment, right? And we do the same thing here. We just say labels, labels. And there is a fundamental difference between the two, and that is that the labels, let's say we make an assumption that they need to be provided, right? Labels. So we say label description. So maybe here, I'm sorry, maybe we should call this text, and here we should call it a label. Yeah, I messed up before. But yeah, so for the examples, we call it text and label, whereas for the labels, we call this text and label. Let's see what we get. Hopefully this will be something nice. So as you can see, we don't get the description because we did not refer to the right thing. Description. But let me maybe even run that here so that it's more visible. So Python classify, yeah. So as you can see, we now have the right thing. So here we have the definition of the labels, and here we have some examples. And let's write some, let's say, system message, right? What we have in orange here, like general task description. So I want you to classify text for me. Let's do this. I want you to classify text for me. What else did we write there? See below all the possible labels and their descriptions. Fair enough. See below all the possible labels and their description. And what I wanted to change here, I wanted to make these examples optional. So let's say if we are in the 0-shot context, right, we don't have any examples. So what we do is we say if examples, and only under this assumption, we run this block. However, if it's an empty list, right, which can happen, this should be, this should be empty. So, and if, is this enough? See below a couple of examples. Yeah, let's see what we get here. So this looks good, and here we kind of passed the examples. But what if we maybe set this to an empty, just for now, right? What if we set this to an empty list? Again, depends on what you're sending over. Let's see what we get. If it's an empty list, as you can see, it did not include the examples. And that kind of reminds me that this sentence should actually be inside of this if block. Yeah, but this looks good, right? And the only thing left after defining the labels and the examples, we just kind of ask the model to do the classification for us, right? On a new piece of text. Here is the text. So here is the text that needs to be classified. And maybe also in the sketch I annotated things using these quotes, so it might be easier for us to read. That needs to be classified. So we basically have the same format as the example, right? And the only difference is that right now this is something we will read from a variable. So let's say this is the text, so there will need to be a variable that we pass here. So let's say text. I hated the TV show, right? This is, let's say, ultimately the text that we want to know the sentiment of, and let's do it like this. And of course, we don't know what the sentiment is. So what do we do here? We just stop here, and we want the model to fill the rest, right? Basically to autocomplete whatever should be next, and we're hoping that basically the next token will be the identifier of our label. Let's double check our prompt, but I mean, to me it looks decent enough, right? As you can see, it's pretty arbitrary. You can make an argument that it's pretty arbitrary, and I would agree, but this looks pretty good, yeah. And let me maybe also remove these empty lines, because it interprets them as an empty line. So yeah, let's have a look again. So as you can see, this is the thing. I want you to classify text for me, see below all the possible labels. So we defined all the labels, see below a couple of examples. There we go. And here's the text that needs to be classified. And yeah, to me, this is more than enough. And so since we are done with, let's say, the template part, the only thing left, right, as discussed, is the OpenAI part. So let's import OpenAI, and let's go to their web interface, and let's literally copy paste the piece of code that they provide. So we want to use the Python code for this, and let me just paste it in here, right? So OS, we don't care. The environment variable, I already defined it, so there is no problem there. And here we have the completion variable, which basically holds the returned value. Yeah, let's just assume their code works. But the difference here is that here, as mentioned, right, we want the contents to be our prompt. So the thing we just constructed, we want to send it over to the API. So let's try to do this, and let's see what we get. And let's also maybe, let's see what we get. So if I do Python classify, I need to install OpenAI. That's a good point. Python classify. And as you can see, the content, which means basically the predicted label, is 0, right? And is that correct? This was a negative sentence, definitely. So 0 was kind of the right prediction. Let's make it different, right? Let's say I loved the TV show. Let's send it over. And yeah, here, as you can see, it predicted correctly number 2. And yeah, that's the idea of using large language models to do few shot and zero shot, let's say, classification. Let's actually maybe try and do it without the examples. Will it work if I just comment it out, or will it scream at me? No, it works. So as you can see here, our prompt never contained any examples, so we're doing zero shot classification, but still the model was able to get it, which is pretty impressive. Yeah, so that is more or less it. I think this is, let's say, a new paradigm. I think it's pretty useful, especially if you don't have a lot of data, and especially what maybe the Prodigy repo was doing is super useful, because, you know, if you run this blindly on, I don't know, 100 samples, you might actually make some mistakes, right? Or the external model might make some mistakes. So it might make sense to go through this manually and just make sure that the model's prediction is correct. And it's going to be way faster, this, let's say, way of annotating data than maybe asking a human to annotate it from scratch, right? Because here we're just making sure that the model did an okay job rather than forcing someone to do the classification from scratch. I hope you found this interesting. I find this to be pretty helpful, and I guess I will see you next time.